Good morning, ladies and gentlemen. Thank you, Carlos, for this. It's great to be here. It really is also a personal pleasure to further introduce the NaturalHy project for you. As Carlos and also Dave already indicated, that the focus on the NaturalHy project concerns the conditions in which hydrogen can be added to natural gas in the existing natural gas system with acceptable consequences. And next to that, also technologies for selectively withdrawal from hydrogen from natural gas mixtures is further investigated. And finally, the socio-economic and environmental consequences of the NaturalHy project are further investigated. And in fact, this last point, well, that focuses on the main benefits of the NaturalHy project. The focus of NaturalHy concerns the main potential showstoppers for using the existing natural gas grid for hydrogen. And so those showstoppers that might block the accommodation of the natural gas work for hydrogen delivery. So only the main showstoppers. This graph shows a simple natural gas delivery chain. On the left you see the high pressure transmission grid. It's steel, pipelines, compressors included, underground storages. So that is this size and even larger pipeline diameters. From there, natural gas flows by pressure reduction facilities to the medium pressure regional distribution system. Large consumers are connected to that, and very large consumers, for instance power plants, are connected to the high pressure grid. From there, the gas flows further into the distribution grid. Also, there are industrial end users connected to. And finally, it comes into our houses, the end user infrastructure, and finally in our end use appliance. Well, now the idea of NaturalHy is somewhere where it is beneficial, let's say a logic point, to inject hydrogen in the system, as indicated here in the medium pressure location. I already said that, let's say, the high pressure grid is of steel, the medium pressure grid is also made of steel, but the distribution grid, end user infrastructure, that is made of PE, PVC, cast iron. So the idea is to inject the hydrogen here in the medium pressure grid that is further delivered to end users that can use the mixture as such. And there's also the idea that, for instance, by the means of membranes, hydrogen can be taken out from the mixture and used in, for instance, fuel cells. That's the NaturalHy approach. However, if you add hydrogen to natural gas, there's a change of the physical and chemical properties of the gas in the network and to the gas delivered. And that has quite some consequences. For instance, the combustion properties. Adding hydrogen will change the caloric value of the gas. It also changes the amount of air needed for a good combustion of 1 cubic meter of gas. It changes the flammability limits of gas-air ratio of the mixture of the gas. And for instance, it also has an impact on the flame velocity. Hydrogen can also diffuse into materials and change the mechanical properties of the materials. Also, the dispersion of gas in air changes, and this has, for instance, impact on the gas buildup in case of leaks, and also on the behavior of clouds in open air. Well, in fact, all these consequences to these changes are represented in the project organization that we indicated here. The work is organized in work packages. That is a group of partners working on specific issues. Each work package is led by a work package leader. Well, the work packages are indicated here. The work package on durability is focused on to which extent are pipeline materials affected by hydrogen. And I can already say that, that particularly the growth of small cracks is a very important issue in this. The work package on integrity concerns the monitoring, maintenance and repair of pipelines. It defines which measures should be taken to mitigate the impact of hydrogen on pipeline systems. Safety. I already mentioned that the combustion properties are changed by adding hydrogen to natural gas. Well, this also has an effect on severity in case of explosions and fires. I also said that the pipeline materials, the properties of those materials, may be affected by the addition to hydrogen. And this might, let's say, change the probability of failure. Well, in combination with the severity of effects, this may change the safety aspects in case hydrogen is added to natural gas. That's further investigated in the work package on safety. End use. Well, changes the combustion properties, so it's logic that also the performance of end-user appliances are further investigated in this project. And furthermore, in this work package, the work is done on the development of technologies to withdraw hydrogen from the mixture, particularly on the development of membranes, palladium and carbon-based membranes. Well, the output of these 4 work packages is the input of the work package on the socio-economic and on the LCA and socio-economic assessment. In fact, in this work package, the overall benefits of adding hydrogen to natural gas are mapped out. And it is not only environmental aspects that are over important, but also, for instance, the number of jobs involved. And the output of these 5 work packages, in fact, that's the input of decision support tool in the work package. And this work package develops a software tool for pipeline operators to assess the possibilities to accommodate hydrogen in the networks. The work package on dissemination, very important. It concerns the dissemination of results and information to third parties, so that also other organizations can use those results. Dissemination has taken place by newsletters, workshops, website, and also, of course, this final presentation. This shows the management, the management team of the project, and in here you recognize the presenters today on the related issues. Some characteristics of the NaturalHy project. As Carlos already mentioned that 39 partners are involved in this project. It's a so-called integrated project within 6 framework of the European Commission. The project started 1st of May in 2004 and lasted 5.5 years. Our overall budget is a bit more than 70 million euro, and the financial funding by the European Commission amounts to 11 million euro. Next to the group, the consortium of active partners, there's also an advisory committee in which all kinds of stakeholders take place. Quite some, I'm very pleased to see that quite some of these stakeholders are also present today here. And finally, the NaturalHy project is recognized as a project in the framework of the International Partnership of the Hydrogen Economy. Well, just to give you a flavor and not to reveal too much of the final outcomes, generally speaking, we can say that the maximum percentage of hydrogen added to natural gas is limited by, I indicated here, the 3 main things. It's a bit limited from pipeline materials. Safety is more stringent, But as we see it now, that end-user appliances, the performance of end-user appliances, those are the most limiting aspect in the for the NaturalHy approach. This will be further explained by the next authors. Thank you very much. And I would like to invite Gordon Adam for his view as a politician on the NaturalHy project. Gordon, the floor is yours. Thank you.